We're going to start testing each of the windings to case ground, and then we'll move over winding to windings. Again, we're going to test the windings to case ground at 4,000 volts. So prior to me setting this, turning on my meter, I'm going to go ahead and set it up. You want your voltage going through the windings and you want the ground to be connected to the case. Butterfingers. Stay on there. When doing this test, you want to make sure that you're not in contact with any other windings, or your positive is not close to case ground, because we're about to put some serious voltage through here. That being said, we're going to power up our meter. This meter takes some time to turn on. And with this meter, you have to set it to, once it gets there, you can't see it moving. You may not be able to see it moving, but it moves in increments here. So with this meter, I have to first set it to 5,000, go to 5,000, and then I got to bring the 5,000 down to the 4,000 that we're testing at. Now, I'm ready to start testing. A couple of notes of safety that you must be aware of. Though these leads look like multimeter leads, they are special leads designed to have 5,000 volts put through them. So do not use multimeter leads on an insulation resistance tester, or you will burn out your leads and possibly cause damage or fire. So be careful there. And again, we are putting 4,000 volts through this thing. This meter is designed that it drains off voltage after the testing is done, so that you don't need a separate ground to short it out. If you're not comfortable with that, then you take your another device, connect it to some item that's grounded, and you ground it yourself. But I'm going to show you how I do this with the meter. So now that we're set to do the test, we run this test for 30 seconds. So I'm going to go ahead and hit test, and I'm going to hold it, and you will hear my meter come on. And you can see that currently this meter is putting 4,218 volts through those windings. And it's holding a resistance of 5.41 giga-ohms. And as we go up, that resistance is going up. So we're at 25 seconds. At 30 seconds, I'm going to stop it. And we are at 40. We were holding 4218. Voltage 4218. And our resistance is 8.75 giga-ohms. So that would be a pass. We're going to continue with the test. We're going to continue with the test, and I do want to show you how I'm going to hit no. I don't want to save those results. And before I move, all I want to do is I want to take my positive and my negative and short them out. Leaving it here. I want to also just kind of short it just to make sure that we're good. Our next test is Z1 to case ground. And again, I can't let this touch, so Z1 is being a bunky here. Stop moving, stop moving, stop. Good. All right, we're going to start the test. So with this meter, if you notice, this is only holding 14 volts, and it's at 9 kilo-ohms. So if the short is too bad, this meter will stop testing. But we kind of see this is going to fail already. We're holding 14 volts. That's 30 seconds. Let me just short my windings here, make sure I'm good. And we're going to move to our H2 set. I want to make sure that this is touching both my wires so that my test is good and I go through both ends. And we're going to go ahead and start the test, make sure I'm not touching anything. And we just wait out 30 seconds. Okay, we're at 25 seconds and this thing is holding pretty steady at 42.18 volts. 30 seconds, stop, and we are at 9.64 gigaohms. No, short it out. And our last tester case ground is going to be our Z2. And start the test. Oh, 25 seconds in, 42.19, 42.19, that's our 30 seconds. And we are at 23.4 gigaohms. No, let's just short this out. Yeah, having done that, we can see that we knew the back end was bad because it failed a multimeter test. But having put the voltage in, you can see that each of the windings, with this meter, it shows you the amount of voltage that those windings could hold in the resistance value. So we know that our Z1 to case ground, our Z windings are bad, which coincide with Z windings being bad. But we're going to continue on and go with the windings to windings, and we're going to follow the order of the sheet. So we're going to start with our H1 to Z1. The first thing I'm going to do is I'm going to set my meter up again, and I'm going to put my hot on the first number, which was H1. And this one is at Z1. My white. Again, we want to change our values because we don't want to smoke the back end. So we're going to change our value down to 2,000 volts. With this meter, all I have to do is hit my down arrow until I get to 2,000 volts. Now that I'm at 2,000 volts, I'm ready to test. Again, we tested at 30 seconds. So I'm going to go ahead and start the test. See you later, awkward silence. Okay, we're at 25 in. I'm going to go ahead and take my numbers, holding pretty steady at 2,116 volts. And we're at 30 seconds. I'm going to stop it, and we're sitting at 16.8 gigaohms of resistance. I don't want to save that, but I do want to short these out to each other just to make sure. And then I'm going to move over from my H1, since I'm already hooked up to my H1, and I'm going to go over to my H2 as per the sheet. And we're going to go ahead and start that test. And of course, we knew this was going to fail because it failed our multimeter test. So I fully expected to fail this test, and we're coming up on my 25-second mark, and we're only holding 3 volts. That's 30 seconds, and it was at 2 kilo ohms of resistance. Which we expected that, as it failed a multimeter test with 3 volts. So of course, you're not going to put 2,000 volts through this thing and it's pass it. That's crazy. I am going to short this out, even though the meter already shorted it out. And I'm going to move on to the next test, H1 to Z2. My H1 is still hooked up. I'm just going to move over here to my Z2. start the test. We're coming up on our 25-second mark, and it's holding pretty steady at 2116 and 14.8 gig ohms. We do not want to save that. We do want to short these. And my next test is my Z1 to my H2. So I'm going to take this one off and put it on my Z1. And move this one over to my H2. Again, you don't want these things touching anything. There we go. Okay, I'm gonna start the test. Second mark, we're holding at 2,116 volts. And we are at 10.4 giga ohms. We do not want to save those to the meter, and I do want to short these out. Our next test is going to be from our Z1, which we're already connected to. Just want to reaffirm that connection. To our Z2. And we'll go ahead and start the test. As we approach our 25-second mark, again, we expected this to fail. It's only holding at 14 volts. 30 seconds, 9 kilo ohms. We're not going to save that to our meter. We are going to short these two out for safety purposes. And we'll move on to the last test, being our H2 windings to our Z2 windings. We're going to start the test. As we approach our 25-second mark, it's holding at 2,116 volts. We hit our 30-second mark, stop it, 14.3 giga ohms. We're not going to save that. We're going to power the meter down. I'm going to short these out. Okay. Now, last thing to note, our test results from this test. As we can see, it failed our multimeter test on the H1 to H2 windings. When you come down here to H1 to H2, it also failed, which is expected. It failed Z1 to Z2. You come down to our multimeter test, it also failed our megger test, or our insulation resistance tester. But here's the difference, and very important thing to note, again, because this multimeter is only putting 3 volts DC through this, if you notice, our Z1 to ground also failed, which did not reflect in our multimeter test. The last thing that I need to mention before we sign off is we have seen that with test results like this, we recommend that the back end be replaced. But we have seen instances where That back end will still produce voltage, but it's not going to put the power out that it needs. So whenever you have a back end that fails, we recommend that you replace the back end. However, there are instances that with a failed back end, it could still produce power. That has been testing of the Fisher Panda asynchronous marine generators back end. Enjoy.